Good morning, everyone, and welcome to today's webinar, Turning Energy Consumption into Measurable Value with Digital Intelligence, proudly hosted by Australian Manufacturing in partnership with GridBeyond. My name is Kylie Spear, and I'll be your host for today's session. Thank you all for taking the time to join us. Before we dive into today's discussion on digital intelligence and energy value, it's worth setting the scene with where the Australian energy market is headed. According to the Department of Industry, Science and Resources, Australia is rapidly transitioning to a cleaner, more resilient electricity system with a target of 82% renewable energy by 2030, which means renewable generation will soon form the backbone of our grid. But energy from wind and solar needs to be balanced with reliable storage to keep supply stable and costs manageable for industry and households alike. A key part of this transition is large-scale battery storage. The Australian government's National Battery Strategy, central to the Future Made in Australia agenda, recognises battery storage as a critical pillar in Australia's energy future. The strategy aims to expand Australia's energy storage and manufacturing, capture value from local resources, and strengthen supply chains while supporting economic growth. Under the strategy, initiatives like the $500 million Battery Breakthrough Initiative, delivered by the Australian Renewable Energy Agency, focus on stationary storage systems and high-value parts of the battery value chain, positioning Australia to both support its own energy needs and compete globally. So while today we'll be talking about turning energy consumption into measurable value with digital intelligence, it's important to remember that this work sits within a broader context. Australia is building the infrastructure and industry needed to make energy more affordable, reliable, and economically productive for manufacturers and the nation as a whole. In today's webinar, we will explore how manufacturers can unlock real value from their energy use. We'll look at how forecasting, automation, real-time controls, and digital intelligence can reduce costs, manage and turn energy flexibility into measurable value and new revenue opportunities. According to research from GridBeyond, digital intelligence, which combines data, market signals, and forecasting, can reveal hidden energy flexibility within existing processes. This helps manufacturers move from passive energy consumption to proactive real-time control and cost management. So let's meet our speakers for today. First, we have Chris O'Brien, Managing Director at GridBeyond. Chris will guide us through how intelligent energy orchestration, combining forecasting, optimization, and real-time market participation, is helping industrial businesses reduce costs, unlock new revenue streams, and turn energy flexibility into measurable value. Hello, and welcome to you, Chris.
Thanks, Kylie.
We'll also hear from William Salas, Market Strategy Manager at GridBeyond. William will share how manufacturers can transform energy consumption into measurable value through better visibility, rapid response to market events, and smart participation in energy programs enabled by digital intelligence. Hello, Will, and welcome.
Thanks, Kylie. Hi.
We will get started in just a minute. To give a few more people time to join while we wait, we're putting up a quick poll for you all as a fun little icebreaker. You should be able to see the poll appearing on your screen right now. And the question is, energy is central to business resilience and sustainability. So what do you see as the most pressing energy-related challenge for your organization? And your options are A, navigating rising energy costs, B, understanding and tracking energy usage effectively. C, balancing energy supply and demand during peak periods. D, meeting sustainability and emissions goals. Or E, exploring and implementing energy optimization strategies. So we'll give you all a few more seconds to plug in your response before we flash up the results. I think that's probably enough time. All right, let's take a look at our responses to that poll if we can. So, well, it's quite close, and I think it's almost a bit of a tie there by the looks of it with respect to A and C, if I'm looking correctly. Yes, navigating rising energy costs and balancing energy supply and demand, followed by understanding and tracking energy usage, and then D, meeting sustainability, and no response for the optimization strategies. So really interesting to see that come through in that spread there. And it does make sense given the current environment, highlighting just how quickly energy has moved up the agenda for organizations, not just as a cost center, but as something that directly impacts resilience and future planning. I guess what this tells us is that regardless of where you sit, there's a shared need for clearer insight and smarter decision making around energy, which is precisely why we are here today. So thank you very much to our audience for your responses. Before we begin, just a quick bit of housekeeping. If you have any questions during the session, please type them into the question box in your control panel. We will address as many as possible during the live Q&A at the end. And just a reminder that today's webinar is being recorded and a copy will be sent to all attendees afterwards. With that, let's get started. Kicking off our session, please welcome Chris O'Brien.
Thanks, Kylie. Let me start by sharing my screen and getting this into the right. Okay, has that come up okay, Kylie?
It sure has. It looks fantastic, Chris.
Okay, great. All right. Well, thanks everyone for joining, and I appreciate you taking the time out to hear about this topic. This is something that we do day to day. It's bread and butter for us. So the digital control concept of energy management is really core business to us. So we started in 2010 in Dublin, in Ireland, as essentially a controls company. And the controls side of the business was essentially working behind the meter. So with large industrials, like the people that are joining this meeting today, in controlling loads to optimize energy outcomes. So we've evolved from that point now to be operating in deregulated markets around the world. So we're active in Japan, Australia, the US, 5 different markets in the US, obviously Ireland, where we started, and the UK. The load portfolio we're controlling now is close to 5 gigawatt. And part of the energy assets that we do control are batteries. And these are both behind the meter and front of the meter. We're effectively a software company, so you'll see the employee count is relatively small. But what I would say is that over half of those employees are software development or data science engineers. You'll see the partner band at the bottom of this slide where we talk about the people we're working with. And many of these companies are in fact our investors. ABB, EDP, Energy Impact Partners, Yokogawa, Chiyoda, Constellation are all shareholders in GridBeyond. And Samsung just jumped in as a shareholder last week. We announced it formally. So moving on to Australia. We've been in Australia since 2022, and we started as a company that was involved in the demand response markets, so primarily FCAS. If you jump on the AEMO website, you see that the registered portfolio for us is around about 600 megawatt. And out of that, we're involved in all of the FCAS markets, the contingency and, all contingency markets, I should say. And in fact, the R1S market, which is the very fast 1 second market, we are the largest aggregator in that market. very small headcount in Australia, but we cover all the key functions. So we have the ability to audit sites and deliver projects. We have market and regulatory support, which is Will. You're going to hear from Will shortly. But importantly, because the NEM is a very particular market, energy only, 5-minute market, software development and data science locally are key functions that are required to produce the right products to participate in the market here. These are the industry segments that we work across globally. So you can see here they cover a very large spread of manufacturing or industries. And the reason that we can cover so many industries is that the logic is pretty well the same. The logic is about controlling loads against markets and optimizing for value. And I sort of touched on previously that we're controlling batteries. So, if you think about optimization of energy occurs wherever the energy asset is. And many of these assets are being built in what we call front of the meter, so utility scale, but effectively supplying energy directly to the grid rather than behind the meter, which is all about supporting a load. So we have a lot of batteries globally that we're optimizing front of the meter, and that is optimizing when energy is discharged or charging the asset. And, these might be standalone wind or solar assets as well, where we're guiding the owners of those systems when to dispatch or when to curtail energy when we have negative price events. So we're really here to talk about behind the meter energy management. So BTM, behind the meter energy management. And firstly, and really just defining the challenge, we need to recognize that manufacturing typically brings together many individual processes, each with their own energy loads. Some of those loads will be more flexible than others, but we do need to view them as an interdependent process flow. So if we look at a level above your site's manufacturing process, you may or may not have solar. You might be looking at a battery. And obviously that's why this slide is calling out this. I'm going to get my laser pointer open. So obviously above the loads, there are other distributed energy assets, but there's also the grid. And the grid provides an opportunity for the interface between the site's energy assets, including load, to create value. So this all generates a lot of data. And while SCADA typically makes key data points visible to plant operators, it falls short of pulling all the energy assets together with the objective of optimizing value. And successful behind the meter energy optimization requires this data-led approach, but it also requires a system that has the capabilities to operate all energy assets and their interactions. And you'll see here we've used the same graphic, right? Demonstrating the assets and replacing the arrows in the center with an energy management system. So an EMS or an energy management system is what brings together the decision variables and automates the interactions between the assets to optimize energy value. So an effective EMS will simultaneously optimize industrial loads against localized energy assets and the energy markets within any defined constraints. So, a couple of those constraints might be you want to stay under a certain peak demand. So, if you're considering a peak shaving type approach, you want to keep those loads down. So the optimization may move energy around with behind the meter to ensure that you stay below those peak demands. There might be ramp rates as a constraint as well if you do have a battery. So the optimization or the energy management system that houses that optimization takes into account any constraints that are defined for it. So with energy data and the ability to control energy flows within EMS as the foundation, we look to categorize your load components into flexible and non-flexible. Understanding inflexible load is why it is that way should stimulate thinking about how to deal with it, whether it be through energy contracting or even considering a battery behind the meter to support that inflexible load. The way that we define flexible loads are those loads that could be modulated up or down, typically for short periods of time. These flexible loads could create value for you in energy markets without impacting your daily or weekly productivity. And you'll see here on the left-hand side of the slide some screenshots from our platform. Our optimization process or solver ingests data from your production process, noted here as the digital twin, and contrasts the digital twin against energy markets and solves for value without compromising on your production plans. So I've got a little bit more on that in a couple of slides. So as a high-level demonstration of this concept, you can see this first bar chart up here on the left. And this shows a typical 24-hour load curve. And the line shows the energy price curve over the day. So this is one approach. So this is approach A, scenario one, where without understanding the flexibility in your system, you could go out and hedge that entire load curve. Now, obviously, there's a cost to that hedge. In this scenario, your consumption will be fully hedged and it eliminates your price risk, but you're paying for that premium in a premium. And at the same time, it eliminates your opportunity for upside revenue. So you'll see here, this is designed to be the same load profile. But what we're doing here is we've identified that half of the load is flexible. And we're increasing that ramp or that utilization of that load up to this 8 megawatt cap in the early parts of the day. You'll see here in the lines below, the bar chart falls short of that 8 megawatt line. And the reason we're doing that is because the energy price is low. So we want to increase production during those periods of time. So those flexible loads increasing to the 8 megawatt mark in lower price times during the day. And that creates the flexibility during the higher priced periods during the day to modulate that flexible load down. And this is creating value either in the WDRM market, and you hear about that shortly from Will, or in your wholesale spot market. So circling back to that digital twin concept. Firstly, the term digital twin is used by many industries, and it's probably a similar definition to in all industries. However, I'm going to call out the definition here. The definition of a digital twin is a virtual model of the physical assets that you have on site. And where a production process has many steps, as part of our onboarding, we audit the process and build a virtual model that reflects the interdependencies of the equipment and the throughput. So through this auditing process, we identify initial flexibility in your process, as well as any operational constraints. And once in place, our digital twin will ingest all your production schedules and your targets. And once we have our solver will create recommendations for the plant operation that will optimize value against markets. So overall, the objective is to help you reduce your marginal cost of production. And I'm going to use an example here so that the foundation of our energy management platform is a 7-day price forecast. So an energy price forecast for the next 7 days. And you can see this here. This is this turquoise curve. Our optimizer looks at your production plan and the constraints of the asset and determines how to lower your energy costs and create upside. As an example of this concept, consider a glass furnace. So a glass furnace has they're typically gas-fired with an electric booster. Those electric boosters typically have a 2 megawatt or 2 or 3 megawatt power rating. So the booster is used to maintain the molten bath temperature within the thermal constraints to ensure the product quality and furnace health. So the red line here is the booster power charted against that energy price forecast. you can see we're recommending increasing the booster power in low energy price times and modulating it down during during higher energy prices. So we're effectively driving bath temperature in that glass bath temperature up during low price times, and we're using the thermal inertia to modulate the booster down, create flexibility, create value, whilst maintaining the production and throughput during periods of time where energy prices are higher. So we're effectively using the booster as the flexibility. So this concept is transferable to many industries: aluminium production, metal manufacturing, cement, air to gas, to name a few chemicals. So what does it look like from a technical view? So from a high level view, we interface with the site through an edge device typically. When we're talking about many different assets, we'll put an edge device on site, and that would be a panel, maybe a small panel, 400 by 600 mil. Inside of that panel would typically be our controller alongside an industrial PC, a modem, and a VPN. And if we were taking you into some of the frequency markets, the FCAS markets, we'd also have a mass compliant FCAS meter in the panel. So from that panel would be a Modbus TCP connection to your SCADA system. And the combination of our cloud platform, digital twin, and edge device allows us to take you into market. So interface your site, your flexibility with the market. And the market here is shown up the top here. And I'm going to hand over to Will now to provide more opportunity, provide detail on the opportunity that exists in those markets. Will?
Thanks, Chris. So just a quick recap on what Chris has walked you through, which is the intelligence and technology layer, which is the forecasting, the digital twin, and the optimization engine. What I'm trying to briefly summarize here is how to connect the technology to the commercial reality and provide an overview of these different characteristics of each type of service. So the services are the rows, and the ideal types of load that might be suited to a given service. Specifically, what markets can you actually access, and what's the value on the table? So I've broken them down in terms of how I think of them, but basically the top section there is what we call wholesale energy, and most people will know this as the NEM, or the wholesale energy market, or the spot market, and this has a breakdown of 3 different services, and essentially these 3 services all operate in the wholesale energy market. So you might have heard of spot price avoidance, or another name that your retailer provides you access to if you're on a fixed contract. If you're on a fixed contract, you could also participate in wholesale demand response mechanism. That's the second row. And then there's a more emerging mechanism, which is called the voluntary scheduled resource, and the voluntary incentive mechanism, VIM, VSR and VIM as we refer to them. And again, these are all essentially operating in a similar way, where wholesale prices spike, you reduce load or flex whatever on-site resources you might have, depending on the particular service, and you get paid at that spot price for the given reduction, or it could be an increase in some of them if you've got on-site generation. As you can see on the right, I've got sort of these high-level descriptions of the characteristics of these programs. So I've tried to give you a flavor of the response speed, the typical duration of the event, frequency, on a month or annual basis, and whether it's a avoided cost. If you're a spot pass-through customer and you've got some sort of spot price avoidance arrangement, then you're avoiding those high prices. But conversely, if you've got a fixed contract and you've got a retailer who's paying you to participate, or you could be in WDRM or VSR, then you're actually getting paid revenue, which is obviously going to your bottom line. And then there's the other dimension to consider, which is, you know, the value, and that is the revenue, which is going to depend on where you are located in the NEM. Obviously, energy prices vary across regions, from, you know, Tas to Queensland, and I think that's all I wanted to say on that. So this is, it sounds simple in theory, but the challenge has always been executing these services for loads without disrupting production. And that's what the digital twin solves. It knows what your plant can do and what your plant can't do before we send a signal. And people who've had some experience with just demand response will remember back in the day, you might get a call or text from your aggregator or retailer, and someone on site will run down to plant and turn it off. That's the sort of where things started out. And then you might have evolved, if you're a more sophisticated customer, to having a device on site. And instead of having an operator physically run down and turn equipment off, that device is connected with your on-site EMS, SCADA, maybe directly to the PLC, whatever it is, and performs that function for you. And then the evolution of that, again, which is where we are today, is the optimization. And so essentially what we're trying to do is make it easier for the site, lower risk, and still enable participation in what would be seen otherwise as a maybe risky or difficult service. So I just want to again touch on VSR and VIM. This is new. The VIM is essentially a pot of money that's being handed out by ARENA to aggregators to encourage sites and loads like manufacturing to participate. And essentially, you would still have your fixed contract, but you're accessing the energy market to generate revenue in exchange for participation, which will look something along the lines of what I've put there in terms of the response duration, etc. And it's also worth noting, I think often customers get a little bit scared off by DR because they, well, my site can't respond that quickly, or it can't sustain a response for however long is required. And this can all be tweaked by the software. So if your site can only respond for a 5-minute block, that's no problem. We coordinate accordingly in the back end to make sure that the digital twin would never dispatch or control the site that wouldn't be in line with how the site needs to operate. So FCAS is the next one down in purple. I think a lot of people will have heard of that term. It was a hot buzzword for several years while we had a fair bit of thermal generation exiting the market, and there was a gap, which meant that supply and demand was out of equilibrium. Anyone who's a bit of an energy nerd like myself will know that the FCAS prices have softened dramatically, and it no longer has the same value that you might have heard from about it a few years ago. That said, what I will say is it is a frequency balancing service for contingency events, for unexpected events. Those unexpected events will still happen from time to time. And if you can capture that value, it can make, in concert with the other value streams that you might be able to stack, a significant benefit in terms of the overall revenue. The challenge with FCAS for most sites is the speed of response. You typically want a site that can respond in seconds, not minutes. So that's generally how we determine whether or not a site is suitable for contingency FCAS. And as Chris mentioned, we have one of the largest portfolios of the very fast service, and so our technology has been built around that. What's the next one? So then I'd break it down into outer market. So we've covered at the top energy, then we talked about FCAS, and this bottom section is how I think about it, is just out of market products. I think a few of you will have heard of RERT. RERT is essentially what AMO call a backstop. So it's when there's a tightening in supply and demand of the bulk energy system. And typically these used to happen on very hot periods, heat waves, where there's potentially going to be a lack of supply, and we would basically ask customers to curtail, and it's dispatched or triggered, scheduled, however you want to think about it, by AMO. And it is a bit of a more of a old school kind of program, but it's still in operation, and it can still, again, when you stack it with other services, contribute to value. Under that, network demand response, these typically are your local DNSP program, so you won't be able to access these across boundaries of other DNSPs, but if you're in an area where this has been required, you might know about it. And these, again, out of market, you'll have a direct contract, and then our kit would allow you to participate in that without having disruption to plant. And the last one there is network tariff optimization. And this is, I think, something that most people will have heard about and has become a bit trickier to access in terms of the value, but essentially we're trying to trim demand charges. So this typically is best suited to really flexible sites, or those sites that might have a battery, where we can actually offset the fixed load, because you'd already be flexing the flexible load, hopefully pulling it out of those high demand periods. So I've covered quite a few different, there's more revenue streams in the market, but these are the ones that I think people have typically heard about. What we commonly see is people on fixed contracts that want to access the wholesale market and don't know how. That the wholesale demand response, VSR, VIM, that's really a great starting point. Low risk, doesn't impact your fixed contract, but allows you to turn any flex load into revenue.
Okay.
That's it. Thanks, Chris.
Thanks, Will. So just rounding it out, I've got 2 more slides to close this out. So many production sites already participate in demand response, as Will sort of alluded to, in one form or another. And that's good. It provides a good starting point in the energy optimization journey. But really where the rubber hits the road is where you can create value through using your production processes as flexible energy assets. And to do this effectively, safely, and with longevity in mind, production constraints need to be accounted for. And this is what I call energy-aware production scheduling here. So this middle point. It's an integration of the manufacturing processes with the markets, leveraging market volatility to create value. So the next step is for those manufacturers that have multiple sites, which is this final step. Our platform both optimizes at a site and a portfolio level against the market, but I'm not really going to go into that. So if you are interested in this type of engagement with the energy market or with an optimization concept, what's the first step? Well, we start with a generic model. And this is the model prototype on the left-hand side. And we model your loads and energy data to create a view of what is possible. We then dig a little bit deeper, providing we get some numbers out of this generic model that are interesting to you. We can go a little bit deeper and look at your specific assets on site to try and tighten up the model and be more confident around the value that can be created. And then we'll run some backcasts and we'll iterate, and then there'll be finally a proposal that talks about the value that can be delivered. So generally, that iteration and through this journey might take you, 4 to 6 months to get to a point where you can really understand what the value available to you is through engagement with optimization, digital twins, and the energy market. So that's where I stop now, and I'm going to hand it back to Kylie. So back to you, Kylie.
Thank you so much, Chris and William. This is absolutely fascinating. Let's quickly recap the key takeaways for everyone joining us today. We have learned that Energy management is more complex than ever, and a reactive approach just isn't enough. Businesses that combine forecasting, automation, and real-time controls can turn untapped flexibility into measurable value, reducing costs while maintaining production. Timing is key, with fast responses unlocking programs like demand response or spot price avoidance, and smart systems make that possible. Ultimately, energy is no longer just a cost, it's a strategic asset. Okay, well, we'd really love to hear from you again, audience. Let's take a moment to launch our second poll of today's webinar. As you can see, it should be appearing on your screen right now. The question is, which of the following best describes your organization's approach to energy management today? A, energy is mostly treated as a fixed operational cost. B, we monitor energy usage but don't actively optimize it. C, we're exploring energy optimization technologies. D, we actively optimize energy use within our operations. And your final option is we're already participating in flexibility or demand response programs. I cannot wait to see what our poll says. I guess wherever you're sitting in this spectrum, presumably the opportunity is in the movement. Chris and Will, I'd love to get your expert commentary on these results. We might flash them up on screen now to see what we have. Well, there you go. B, we monitor energy usage, but don't actively optimize it. Chris and Will, does that response track with what you're seeing out there?
Yeah, I think that's pretty typical of the smaller manufacturing sites.
Yeah.
I think as the size of the energy ticket grows, there's more and more of a drive to optimize energy. But also, I would say that most people don't know how to optimize their energy. So there's a whole education piece around how to optimize against energy that, people that are serious about taking that journey will start to educate themselves on. Yeah.
I'd add, Kylie, that one of the greatest challenges I see for the sort of smaller C&I sites. So as Chris mentioned, in really large sites, you'll at least have a person, if not a team, looking after energy, and therefore that's their job, is to optimize, essentially reduce energy spend, however that may be possible. And so, as he mentioned, they're generally very literate. They're people we can talk shop with. But if you're newer to the space, it's generally seen as the greatest challenge is finding and identifying the flexible load. And generally, most people who haven't had experience with DR will say that they have no flexible load. But I haven't come across too many sites that doesn't. That's true, that we can find something. And I think that's the important starting point, is identifying where that flex load or resource, the resource is obvious, if you've got a battery, very straightforward. But if we're talking about loads, then it's all about what is that flex load, and then how can we use that to participate.
Yeah, for sure. I think it's a really honest reflection of where many organizations are today. So thank you to our audience for their responses to that poll. Before we move into the Q&A, it's worth stepping back and looking at the bigger picture behind everything we've discussed today. At a national level, the Australian government's national battery strategy under the Future Made in Australia agenda focuses on expanding energy storage and building domestic capability to support a more reliable and flexible energy system. But infrastructure is only part of the story. It's also about how businesses use energy. As GridBeyond highlights in its latest white paper, many manufacturers still separate energy from production, which means missing real cost-saving opportunities. What we're seeing now is a shift from reacting to price spikes to using forecasting, AI, and real-time control to align operations with the market. So instead of energy being just a cost, it becomes something you can actively optimize and turn into value. Okay, now let's hear what's on your mind and open it up for questions. Please feel free to drop any questions you may have in the chat, and we'll cover off as many as time allows. Chris and Will, we've had a few come through already, so I'll just throw them out to you both. First up is many manufacturers still see energy primarily as an operational cost. What's typically the first step in shifting toward a more strategic energy management approach?
Yeah, I think Will touched on it before. It's really understanding that you have flexibility, and once you've identified that you do have flexibility, then understanding the value of that flexibility, and that can really only be done with some level of monitoring.
Thank you very much. We'll jump in if you have anything to add. Otherwise, I can move on to the next question we have.
Yeah, sure. I just think I'd just add to that is to remember that on the control side, it's a journey. If you haven't done this before, it doesn't need to start out automated. We usually have many points of interference in terms of the customer always being in control. This isn't no optimization, no demand response, therefore you're fully in control, to participating somewhat and losing control. That control is always with the customer.
Sure. The next question that we have is an excellent one. How can businesses identify genuine flexibility in their operations without disrupting production?
Yeah, so that's an auditing process fundamentally, but the concept is trying to understand the interdependencies between each stage of the process, and then working out each part of the process, is that operating at 100% or below 100%? Do you require each step of the process to be operating at its optimum to keep your production moving, or can you modulate and still achieve the targets, still achieve your production targets? So we usually work hand in glove with customers to understand where the flexibility lay in their process, and then understand, how much flexibility is there. So both on time and on power.
Sure.
And I think it's worth noting people like GridBeyond, who work globally, worked across pretty much every sector you can think of that would be suitable for DR. So, a first call, they'll be able to tell you based on already knowing how your sort of facility generally, yes, there's nuances, and for sure across the world, environmental conditions, etc., will change subtly how these processes function. But the business has a lot of experience with these different sectors, and will be able to, immediately identify what we would expect, where we would expect there to be some flexibility.
Yeah, sure. That makes sense. And Chris and Will, we might squeeze in just one final question in the time we have remaining, which is for manufacturers just beginning their digital energy journey, what early wins should they focus on?
Well, I think the early wins is understanding the data you've got, and does that give you any indication in terms of the flexibility that you might have in your process? I think the first step is, if you've got the data, then it comes down to looking at that data and trying to understand how that data is constituted through the process, and through that. The early win is really just trying to break down your production process and understand it a little deeper.
Sure. Yeah. Any thoughts, Will?
Yeah, I have a background in data analysis, and so yeah, fully support what Chris said there. And I've spent a lot of my career just sifting through data. And what you'll often find is operators who are very intimate with their site. Obviously, the backbone to sites operating efficiently will have a view, And like all of us, you have some biases, and the data might give us a different view. And aligning those two is, the foundation to setting this all in train. So every customer in the NEM has a type 4 metering installation, essentially that means you're a contestable site. At the very least, even on the most rudimentary site, you have access to 5-minute data from your retailer. I dare say that most people here will have more granular data than that. They might have some check metering, maybe an EMS, maybe a SCADA, and they're going to get really granular data. And obviously, painting that picture of how the processes work and the interdependencies, as Chris mentioned, is really can only be done using that interval data, that granular data.
Yep. Okay, fantastic. Well, thank you so much to our audience for such thoughtful questions. And of course, a huge thank you to our speakers for sharing their insights with us today. What we've learned is that energy is no longer just a cost. It is a powerful lever for efficiency, resilience, and competitiveness. And with rising prices and evolving markets, manufacturers need to manage energy strategically, and digital intelligence is making that possible. By combining real-time data, analytics, and AI-driven optimization, businesses can unlock flexibility and turn energy into measurable value. So thank you again for joining us today. And don't forget to follow Australian Manufacturing for more industry insights and upcoming events. We look forward to seeing you at the next webinar.
Thank you all.
Thanks.
Bye.